All right, hey Trig, this is section 4.4. We're going to go over the second half of this today and hopefully finish up this section. And we are, I think, on like example 3. I'm going to talk about this box really quick though. But example 3, we've got 3, 4, 5, and 6. So just the second half. Grab your unit circle so that you have him close by so that we can go through some of those things. I'm going to talk about this box in reference to your unit circle. And so that will help you, this box, and I guess your unit circle will help you do the remaining examples. This little chart right here, basically what it boils down to is that like these first 3 rows and columns here, or four rows, 3 columns, if you can figure out and remember these, I mean, I don't necessarily have them memorized, but if you know those first 2 columns, like the sine and cosine of 30, 45, and 60 degrees, you can figure out all of the other places on the unit circle, okay? So if you guys look at your unit circle, you have a 30 degree, a 45 degree, and a 60 degree. And those are the only 3 that you have mapped out on your, in your first quadrant, okay? Then you have 0 degrees and you have 90 degrees, right? 30 degrees will end up being the same x and y coordinates, or sine and cosine, as like 150 over here. And the same thing with this one down here, which is like, what, 330 or something like that, 330, 150, and then this guy would be like 210. Those are all going to be the same xy coordinates. It's just that, so like, let's pick on sine, okay? The sine value is 1/2 over here. For 150, he will also be 1/2. For 210, because the y coordinate is negative, like you're going down, right? He would be negative 1/2, and for 330, he would be negative 1/2. So it's just that like it's going to be the same value, but just a different like sign depending on what quadrant that you are in. For cosine, the square root of 3 over 2, since we're in the second quadrant and we're going left, an x coordinate is negative in the second quadrant. Here it's going to be negative square root of 3 over 2 as well. And here it's going to be positive square root of 3 over 2. Okay, because we're going to the right for the x coordinates. So the x coordinates are positive when we're going to the right, x coordinates are negative when we're going to the left, etc., right? And that's the same thing for like 45, 60 degrees, you know, all of those are going to be the same. So 45 degrees will be the same thing as 135, 225, and then 315. 60 will be the same here as whatever, 120 and 240 and 300. Okay, those will all be the same, just a different sign depending on what quadrant that you are in. So what I want you to do is, let's make another little chart right here real quick. We need to add this to your unit circle yet. I want you to, in this little chart right here, put this down. I'm going to do an x, y coordinate, and then we're going to do tangent. And we're going to do an xy coordinate, and then we're going to do tangent, and then xy, and we're going to do tangent. And this is just telling you the sign of everything in each one of those quadrants, okay? So as far as xy goes, in the first quadrant, he is positive and positive, which means tangent is positive, okay? Like the x coordinates are positive, the y coordinates are positive, all in the first quadrant, everything's good to go. In the second quadrant, the x coordinate's going to be negative, but the y coordinate's going to be positive. So negative, positive, that means tangent, since tangent is sine divided by cosine, he will be negative, okay? And I know we've written this down before. In the third quadrant, he's negative for x, negative for y, so negative, negative. That means tangent is positive, because a negative divided by a negative is a positive. And then in the fourth quadrant, we are positive on the x and negative on the y, which means tangent is negative. Okay, I'm going to pick on Reese. Reese said this kind of brilliant thing the other day, and I was like, oh my gosh, I've never even thought about that before. Okay, so let's talk about like if you have a dot here, right, and a dot here, okay, in the second and fourth quadrant, tangent is negative because the slope is negative. I never really even thought about that. Like, as tangent has to do kind of with slopes in calculus and stuff. And so negative slope, negative tangent in both those quadrants. Versus if you have dots in the first and third quadrant, your slope to the origin is going to be positive. So tangent is positive in both of those. So that was really brilliant. So if that helps you to remember the sign of tangent in each one of those quadrants, perfect. All right, so using reference angles, sine of 240 degrees. Okay, so 240 is going to be here in the third quadrant. And they want us to use a reference angle. So if you remember, reference angles is just like the angle of your bow tie, right? 240 is going to be all the way around from here to here. 180 is just that much. So when I'm figuring out a reference angle, it's like in the third quadrant, like how much more did I go past 180 basically, and my reference angle is going to be 60 degrees. Okay, so here if we're trying to find sine of 240, I know my reference angle is 60 degrees, so all I need to do is look at this chart and say 60 degrees, sine is square root of 3 over 2. Cool. Except in the third quadrant, which is where I am living, sine, the y-coordinate, is negative. So the only difference is he's going to be negative square root of 3 over 2. And that's how I can use my chart and my signage and stuff here to and my reference angles to figure out what that value is. Okay, tangent of negative 225. Okay, I'm going to add 360 to that. So that I can find out a better angle. So 360 and negative 225 is, I don't know. I'm trying to do math. I'm trying to math in my head. 360 minus 225. I'm going to do the longhand way. Blah, 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 blah. I can't math right now. 135. I don't know why I can't think of that. 135 is in the second quadrant. Whoop, right there. This is 135 degrees. But as far as a reference angle goes, when I'm looking for a reference angle, I'm looking for like this bow tie angle. So it's like here to here is 180, and I'm only going 135. So what's that little angle right here? And this would be 45. If you take 180 minus 135, that would be 45. My reference angle is 45. So I'm just going to look up, and I'm going to go 45 degrees, and I'm looking for tangent, and tangent is 1. So the answer for tangent of negative 225 is going to be 1, except let's figure out what his sine is. In the second quadrant, tangent is negative, so he should be negative 1 instead. Okay, all right, the last one is secant of 11 pi over 6. Okay, so I'm going to ignore these last two or these last three columns on here because to do secant, I'm going to just go off of cosine. Okay, so and then we'll compare what secant has. 11 pi over 6. Okay, we did some whiteboards on Friday if you were in class on Friday, and we talked about where 11 pi over 6 is going to live. Okay, so like I said, like this is 0 pi. This is 0.5 pi. They call it pi over 2, but I'm going to do 0.5 pi for right now. This is 1 pi, this is 1.5 pi, and then 2 pi would be back the same spot as 0 pi. 11 over 6, if you divide those, that's almost 2 pi. So I know 11 pi over 6 is going to live here, okay? 11 pi over 6, that would be like from here around to here, okay? If I go the whole way, that would be 2 pi, and 2 pi as a denominator of 6 would be 12 pi over 6, right? So like how much more do I need to go? What would my reference angle be in order to get all the way through? If I'm at 11 pi over 6 and I need to get to 12 pi over 6, I need to go another pi over 6 over, right? And pi over 6 is 30 degrees. I don't know if you've figured that out yet, but like pi over 6 is 30 degrees and pi over 3 is 60 degrees. It's kind of like the reverse of that, right? Pi over 6, 30, pi over 3, 60. Okay, so we are talking about a negative 30 degrees or like, a 30 degree reference angle. Okay, and we're doing secant. Okay, which means we're going to look off of cosine. And so we're doing 30 degrees. We're going to look off of cosine and the square root of 3 over 2. Okay, if you would flip the square root of 3 over 2, it would be 2 over the square root of 3 or 2 square roots of 3 over 3. Okay, you don't have to look over here in order to figure that out. I mean, you can. It's a shortcut. 2 square roots of 3 over 3. That's fine. But like knowing these can tell you what those are. Okay, so there is that. And then secant is cosine, and cosine in the fourth quadrant. Cosine is the x-coordinate, and the x-coordinate is positive. So this will be a positive 2 square roots of 3 over 3. Okay. That's what that value will be for C, okay? All right, let's go on down to, am I making you dizzy yet? Going down to example 4, evaluate trig functions. This is secant of 9 pi over 2, okay? Now, I always look at these when I'm dealing with radians, and I'm like, okay, how big is 9 pi over 2? If I take 9 over 2 and I divide, that's 4.5 pi. That's way bigger than like 2 pi, like one full thing around. You gotta take her out. Okay, I will be done here in a second. I have a little baby who's ready to go to bed. 4.5 pi, that is like a lot of rotations. Like this is 2 pi. This is 4 pi. So it's like 4 pi and then some, right? Okay. So I'm going to, let's reduce him down. I think he's going to end up being reduced down to pi over 2, but let's see, okay? If I subtract 2 pi, which is like subtracting 360, a common denominator over 2, this would be like subtracting 4 pi over 2, right? That's what 2 pi is. If I subtract 4 pi over 2, that's 5 pi over 2, okay? I'm going to have to subtract another 4 pi over 2, which, yeah, we were right, was pi over 2, okay? So 9 pi over 2 is the same thing as pi over 2. So secant of pi over 2 is what I'm going to be evaluating, because 9 pi over 2 and pi over 2, those are coterminal angles. They're going to have the same value, okay? And when I'm dealing with secant, I'm looking for cosine, okay? And so pi over 2 is like 90 degrees, this angle right here. So imagine that I have a dot right there, okay? This dot, if I think about it as a coordinate system, the x is going to be 0 and the y coordinate's going to be 1, right? You can see that on your unit circle if you're looking at that. But just generating that makes sense. Like 0 to the left and right, I've gone 1 unit up, okay? Now, secant has to do with cosine, and cosine is the x coordinate, right? And secant is the flip of 0, right? Like if I take 0 and flip it, 0 as a number is, or as a fraction is 0 over 1. If I flip it, it becomes 1 over 0. And 1 divided by 0 is undefined. So that's what I'm going to get for part A, is undefined. So we're kind of using like we're reducing this value down. We're going to do the same thing in part B. Negative 510 is going to be like a huge negative number. So what I'm going to do is I'm going to add 360 to that, okay? 510 minus 360. I know the 510 is negative, but that's okay. I can't math. I can't think right now. 150, and it's negative 150. So I'm going to add 360 again, which is going to be a positive 210 degrees, okay? And positive 210 degrees is in the second quadrant? No, third quadrant. See, I can't math. 210 lives here. 180 is from here to here, so that means I've gone an additional 30 degrees for my reference angle, okay? And we're doing sine, okay? And sine of 30 degrees is 1/2, okay? So I know that my answer is going to be some form of 1/2, like sine of negative 510 is going to be 1/2, except is it positive or negative? I don't know. Sine has to do with the y coordinate, and the y coordinate in the third quadrant, y is going to be negative because we're going down to get to that spot. The y coordinate's negative, so negative 1/2 is what that value will be, okay? And there you go. We're just using kind of shortcuts and like the way that things fit together to try to figure out what some of these are, okay? All right, now these, example 5 and example 6, these are my favorite. I like these because these aren't like negative 4 over 7. You don't have one of those on your unit circle. Like you only have like square root of 3 over 2 and square root of 2 over 2 and 1/2 and those things, right? Like that's all you have in your unit circle. But negative 4/7, they're saying sine of some angle is negative 4/7. And all that means is that like angle theta must be a number that is not an interval of 30 degrees, of 45 degrees, or of 60 degrees. Maybe angle theta is like, I don't know, 24 degrees or something like that, right? Like it's going to be some number that's not on your unit circle. It's just not going to be a nice angle like what's on your unit circle, okay? So let's do this. Sine is negative, okay? This piece of information and then this piece of information is going to tell you exactly what quadrant you need to be in, okay? So sine is negative, and sine was the y coordinate, and your y coordinates are negative here and here, right? Like that's down, your third and fourth quadrant. But then they say cosine is greater than 0. That means cosine is positive, and cosine is your x coordinate. So they're saying my x coordinate's positive, but my y coordinate's negative, basically is what they're saying. x equals positive, y equals negative. So we said y is negative here and here. Which one of those coordinates or quadrants is the x coordinate positive? That would be here, right? So I know from those two pieces of information that I'm dealing with a triangle or a coordinate that's in the fourth quadrant, okay? And I'm going to use this information to label my coordinate, okay, or my triangle. Sine is opposite over hypotenuse, okay? So the opposite side is 4 and the hypotenuse is 7. And one of those is going to be negative. Not both of them, just one of them. And since my hypotenuse is never negative, my 4 has to be negative. And that makes sense, I guess, because I'm going down also to get to that point. So the 4 has to be negative. Then it says find cosine and tangent. All right, before we do that, we've got to find this third side. So we can do the Pythagorean theorem. I'm going to call this guy a. So a squared plus negative 4 squared equals 7 squared. A squared plus 16 equals 49. And if I subtract 16, I get 33. And we take the square root. And 33, I don't think breaks down like 3 and 11, but that's not going to work. So let's just leave him as the square root of 33. Okay, then they want me to find cosine and tangent. Oh, by the way, my angle theta lives in there, like in this tight corner right here. Okay, cosine of theta equals tangent of theta equals. We're just finding what those guys are. Cosine is a over h and tangent is o over a. Okay, so a over h. The adjacent over the hypotenuse side, this is square root of 33 over 7. That's it, and he is done. We don't have to rationalize it all. But then we have tangent, which is opposite over adjacent, and he is negative 4 over the square root of 33. But then if I rationalize and I take him times the square root of 33 over the square root of 33, and some of you guys do that in your head, and that is totally awesome. But that's what he will be, negative 4 square roots of 33 over 33. Okay, that is what he is. Okay? And so it's kind of like a little puzzle-ish. Like these two pieces of information tell you where your triangle is located, and then you just draw him and figure out what the rest of them are, okay? We're going to have kind of the same like little decoding thing down here in example 6. I don't know why they gave this to you again, but they list out the Pythagorean identities, they list out the reciprocal identities, all that good stuff, just as like a, hey, keep this in mind that this is a thing, you know, whatever. But I don't think you actually even use that for this. This example 6 is going to be very, very similar to example 5. They say cosine here is negative, and cosine is the x coordinate. So for now, we have x is a negative coordinate, right? Negative 3/5. So my x's being negative, the x coordinates are the ones, like if x is negative, then we're going to the left, so he's either here or here, right? And then they say for theta that's in quadrant 2. So they tell me specifically we have to be in quadrant 2 and not in quadrant 3. They just went right out and said it. They didn't even do like the whole, now find what the y coordinate is. And they just said flat out, it's in quadrant 2. No guesswork there, all right? So we're in quadrant 2. We're going to draw a little triangle, and my angle theta lives here. And they want us to find sine and tangent, and that's it, okay? Cosine is adjacent over hypotenuse, okay? So the adjacent side is 3, and the hypotenuse side is 5. Now, 3, it has to be the one that's negative, so I'm going to put a negative here. And then we have to find this guy, okay? One other thing that I probably should have talked about up here, but it didn't come into play, is that sometimes when you find this side that's missing, you might have to change him and make him negative, right? Like if you were in the third quadrant and this guy was negative 4 and this guy was 7, and I found out that this was the square root of 33, guess what? He's going to the left, so he has to be a negative square root of 33. So keep that in mind. I didn't say that over here because the square root of 33 was to the right and he was going to be positive, but like just pay attention to that, okay? So when we do the Pythagorean theorem, and actually we don't even have to, this is a 3, 4, 5 right triangle, which is going to be super nice. We have to question and say like, okay, 4, does that need to be a negative 4 or can he stay positive? Because I'm going up, right, to get to that point, and that's 4 units, that will stay a positive 4 and not become negative. So you have to just be very careful of that, okay? So this is what my triangle looks like. This is going to be kind of simple because I don't have to rationalize at all. I've got sine and I've got tangent, and we've got to find, there's where theta is. Sine is OH, tangent is OA. So sine is opposite over hypotenuse, so that would just be positive 4/5. Okay, tangent is opposite over adjacent. That would be 4 over negative 3, or some of you guys like to put the negative out in front, and that's totally fine. So negative 4/3, that's what tangent will be, opposite adjacent. So that is all. Yeah, that's it. Okay. You should be able to get through the rest of these on, let me see where I'm at, on the homework assignment right here. I think we got through like 26, but then you should be able to do the rest of these guys for homework. So there you go.